Right, who can describe scientific notation? Does anybody recall? So it's some number, right? Call it C, times 10 to some power m. Can that power be positive or negative? It could be either, right? There's one specific restriction on C. What has to be true of C? So it has to have a single digit in front, right? So that means it has to be greater than or equal to 1, but less than 10, right? Because if it was equal to 10, it would have the 2 digits. So as long as C falls somewhere between 1 up to but not including 10, then you're good. Okay? So if you're expressing something in scientific notation, there's a couple ways that you can do it. The first is, let's say we have the following number. Okay. If I wanted to express this number in scientific notation, what I need to do is take all the digits that fall either before or after the zeros, depending on whether you're taking an extremely large or extremely small number. So I'm going to take all of these digits here that fall before my 0. I'm going to write those digits down. And then I'm going to put a decimal after the first digit. Okay, so that's how you establish your C value. And then what you need to do is take it times 10 to the power of, and you just need to count how many decimal places do you move over to get the actual number if you begin at this first, after this first digit. So we move 1, 2, 3, 4, 5, 6 decimal places to the right. To the right is a positive value. So we get our number to be 3.67 times 10 to the 6th. If we were taking an extremely small number, so I left some spaces, and I'll try to do that if I give you large numbers online. I'll try to use spaces. When you write a number, don't put commas on it, because when I put my answer up there, I'm not going to do a version with and without commas. And don't put spaces on them. But when I do it, you'll see commas and spaces to help identify the spacing of these digits. But here it's the same idea. You take all the digits that come before or after. Since we're dealing with an extremely small number here, we're going to take all the digits that come after our zeros. We're just going to write those digits down. Place a decimal after the first one. And then what you're going to do is count to see how many decimal places do you move to get back to your original number. Well, I'm going to start right here. After the first digit, I move 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved 9, so it's times 10 to the, but I moved 9 in the left direction. To the left on any number line is a negative, and so I have times 10 to the negative 9. All right. Questions about this using scientific notation? Okay, keep in mind that an answer like this is that scientific notation? No, because you have to move it one more. You have to put all your digits, put the decimal after the first, and then what would this wind up being? 10 to the what? Third or fifth? Okay, so now think about the properties. So it was originally 10 to the fourth. We have to move one more to the right. To the right is what? Positive or negative? One more to the right. So it winds up being 5.13 times 10 to the fifth. All right, now on your calculators, there is no times 10 to the power of. You don't see that. Instead, what they have on your calculator is this EE key. It's located right here, third button on the left from the bottom, right next to the left of the 4. This represents times 10 to the power of. Okay, so if I wanted to take, let's say, 5.13 times 10 to the 5th, and I wanted to enter that in my calculator, the way I would do it is enter 5.13. But you don't have to do times 10 to the power of. All you need to do is hit this EE button. It's going to display as a single E. And then you just write your power. And so if I hit enter, it would actually display what it looks like expanded out. Okay, but that's how your calculator will display that. So some of you, when we had